Good evening again from NASA's Goddard Space Flight Center in Greenbelt, Maryland. The planning team of stock flight controllers is currently on duty, having relieved their orbit team counterparts at about 6 p.m. this evening. The major event today in the stock was, of course, Space Shuttle Atlantis' rendezvous with the Hubble Space Telescope. We spoke with Mission Operations Manager Keith Wallace just after he completed his Flight Day 3 shift and got his reaction to what was obviously both a busy and rewarding day for his team.
Today we had some challenges. It was a big day for us. This was the day that we're doing our rendezvous. So we haven't seen Hubble in 7 years. The shuttle was coming up. We had to get the telescope ready to be serviced. To do that, there were a couple things that had to be done. So first, you have to turn off any critical hardware, any critical electronics, because when you have something as dramatic as being berthed into the back of the orbiter, you want to make sure you're in a safe configuration. So we had to go through a process of getting the telescope in the right configuration. We had to make sure we're pointed in the right direction. We have to make sure we have the right communication set up. So when we talk with the orbiter, we'll be able not only just to talk directly to the satellites, the teacher satellites like we usually do, but now we're actually talking through the orbiter, which is the configuration that we're going to use for the whole rest of the mission. So we have a series of steps that we have to do to get ready for the orbiter to grab us and then put us in the back of the payload bay. And then after we're in the back of the payload bay, now we have to do some further reconfiguration, because all those things that we turned off before, well, now we've got to start turning them back on again. And now we have to get ourselves in a configuration that's ready for the big EVAs, which are starting tomorrow. Tomorrow is our first big day. You can almost think of this as a baseball game in a sense. You know, we've got to the plate, we're ready to go, and now we're ready to go to first base. And the first thing we have to do tomorrow, we have 2 EVAs. We're going to change out the wide field camera. We have a wide field camera on board, which is installed, and this is wide field camera 2, back in the first servicing mission back in 1993. So we're going to be putting this new camera on board. If you think how digital cameras have changed since 1993, this is going to be the capability that we're going to have now in the future. So the first task we have to do is we have to get this old wide field camera, power it down, get it ready to be taken out. We have to remove the power, because when the astronauts are working on something, you can't have any power there. So we're going to have that camera turned down. The astronauts are going to go out, change that camera out, put a new wide field camera. Then we're going to go through what we call an aliveness test. If you buy just a camera at the store, you're going to do what you call an aliveness test. You're going to turn it on, make sure it works, it has power. That's what we're going to do. We're going to make sure it's hooked up correctly, make sure the astronauts don't have to do anything differently. So that's the first part. Now the second part of our EVA, or extravehicular activity, or spacewalk, is when we're going to change out the CNDH, or Command and Data Handling Computer. And this is the part we had the failure on back in October. So this is a unit that was 19 years old, it failed. We're going to change it out, and we're going to put in we're putting in a brand new old unit. This is one of the flight spares from 19 years ago. We checked it out, we tested on the ground, and we're going to install it, and we expect it to work perfectly. And we're going to go through the same process. We're going to do an aliveness test on that also to make sure it works. After these are done, we later have what we call a functional test. After you bought that new camera and you made sure it turned on, now you're going to check out the different capabilities. You can look at the zoom mode, you're going to look at the panoramic mode, you're going to look at all these capabilities. And we're going to do that functional test to make sure it's functioning correctly, both for the wide field camera and this new SICNDH, this Command and Data Handling Computer. So that's going to be a full day tomorrow.
With Hubble now on its work stand, the telescope is ready for 5 consecutive days of hands-on work by pairs of spacewalking astronauts. Beginning tomorrow morning, the astronauts will install the first of the 2 new science instruments and replace a command and data unit. As a way of giving an overview of the planned 5 spacewalks for the telescope, the following chart gives a graphic representation of all the planned new hardware that is planned to be installed on Hubble. On the first EVA, as mentioned by Keith, the new Wide Field Camera 3 as well as this Science Instrument Command and Data Handling Unit will be installed. EVA number 2 will see the installation of the first set of batteries on Hubble as well as 6 new gyros that are each contained in pair units. The third spacewalk will see the installation of the second new science instrument known as COS, or Cosmic Origin Spectrograph, as well as the repair efforts for the advanced camera for survey. Thursday's spacewalk will see the repair of the STIS instrument as well as installation of some of the new outer blanket layer material that's being put on the telescope. And the fifth and final spacewalk will see the second set of batteries as well as a new fine guidance sensor being installed. The new Wide Field Camera 3 instrument will extend Hubble's capability not only being able to see deeper into the universe, but also by providing wide field imagery in all three regions of the spectrum, from ultraviolet into visible and then into the near infrared. It is this wide, what is known as panchromatic type coverage of light that makes Wide Field Camera 3 so unique. As mentioned earlier, the second major activity for tomorrow's spacewalk will be the installation of the new Science Instrument Control and Data Handling, or SIC-NDH unit.
When you're working with the Hubble Space Telescope program, anything can happen. And in fact, just a few weeks before we were scheduled to launch back in October, the data handling system, the SIC-NDH, went down.
The SIC-NDH is critical to the Hubble Space Telescope because without it, you have no telescope, you have no science information.
NASA administration decided that it would be worth it to postpone the servicing mission so that we could get the flight spare and test and verify it and replace it on this servicing mission.
The SIC-NDH function is to take the data from the science instruments and it formats it, it puts it in a command sequence that is then transmitted to the ground and then deciphered back on the ground. Without it, you have no science information. And by putting a new SIC-NDH up there, you gain the redundancy back and you're not one failure away from no science.
The final activity of the spacewalk on Thursday will involve securing the soft capture mechanism to the bottom of the telescope. The soft capture mechanism will enable the future rendezvous, capture, and safe disposal of Hubble by a crewed or robotic mission. So the Hubble Space Telescope now sits in Atlantis' payload bay near the 22,000 pounds of hardware that will give the telescope a longer life and increased observation strength. The SM4 team here at Goddard will be standing by for tomorrow's spacewalk, which will see the start of work to bring Hubble to the apex of its capabilities. We now return to Mission Control in Houston for NASA Television's coverage of the flight of Atlantis on the STS-125 mission.